Hello, we're going to take notes on section 1.5, day 2, rewriting equations and formulas. So we're going to use these three formulas on the top of the page for these notes. The temperature formula has Celsius is equal to 5/9 times Fahrenheit minus 32. Simple interest is interest that you earn is equal to your principal amount times your rate times time. Time is given in years, and your interest rate is written as a decimal, not a percent. And then distance formula is distance is equal to your average rate times time. So let's tackle this first problem. Example 5a. It says rewrite the formula for temperature. So we're going to solve the formula for Fahrenheit. The equation above is solved for Celsius, so that is equal to 5/9 times parentheses Fahrenheit minus 32. Since Fahrenheit minus 32 is in parentheses, we'll keep that together and we'll get rid of this 5/9 first by multiplying by the reciprocal. So that goes away on the right, and we need to do the same thing on the left side. So we end up with 9/5 Celsius is equal to the Fahrenheit temperature minus 32. To get Fahrenheit alone, we just need to add 32 to both sides. And the Fahrenheit formula would be 9/5 times your Celsius amount plus 32. We're going to use that for our next problem. It says, for example 6, use the formula for temperature. Which has a greater surface temperature, Mercury or Venus? So right now, we see that Mercury has a temperature of 427 degrees Celsius. Venus has a temperature of 864 degrees Fahrenheit. We cannot compare apples to oranges, so we have to convert them either both to Celsius or both to Fahrenheit. And I'm going to convert Mercury to Fahrenheit since I just solved for Fahrenheit. So Fahrenheit equals 9/5 times Mercury is 427 degrees Celsius plus the 32. So when I multiply 9/5 times 427, I get 768 and 6/10. We're going to add that 32 in there and get a final temperature of 800 and 6/10 degrees Fahrenheit. I can now compare Mercury's temperature to Venus because they're both in Fahrenheit. And Venus ends up having a greater surface temperature. Okay, I would like you to pause the video and do the on your own part C. When you're done, unpause the video and check your answer. Here's the answer for the on your own. You end up taking 37 degrees Celsius, putting it into the formula for Fahrenheit, and you get 98 and 6/10 degrees Fahrenheit, which is less than 100. Therefore, your friend does not have a fever. For example 7, we're going to use the interest formula. So interest earned is equal to your principal amount times your rate times time. It says that you deposit $5,000 in an account that earns simple interest. After 6 months, the account earns $162.50 of interest. What is your annual interest rate? So it's asking us to find R. So let's solve for R. I'm going to divide both sides by principal times time. And that gives me my interest rate is equal to the interest earned divided by principal times time. So let's plug in the information we have. The interest earned was $162.50. We'll divide that by the principal amount we put in, which was $5,000, multiplied to time. So time is given in years, but in this problem we have it in months. So we need to figure out, we know that 1 year is equal to 12 months. Well, if I have 6 months, when you multiply, you end up getting a half of a year. So 1/2 of a year. And I'm going to write that as a decimal, 0.5. So that's your time. It is really important that when you're working with fractions, since we are multiplying two numbers on the bottom of the fraction, you must remember that these two stay together. So when we divide $162.50, and we're going to divide that, half of 5,000 is 2,500. So when you do that, you end up getting an answer of 0.065. And when we put that as a percent, we'll move the decimal over twice, and you get 6.5% for your interest rate. Now, I stressed this part right here because in your calculator, if you put 162.5 divided by 5,000 times 0.5, you're not going to get the right answer. If you put it in the calculator that way, you need to put parentheses around your 5,000 times 0.5. I would like you to pause the video and complete part E on your own using the interest formula. Here's the answer for the on your own part E. They want you to solve for the amount of principal you put in. They told you that you earned $500 and it was at a 4% rate, so you need to write that as 0.04 because 4% turns into that decimal, and it was after 5 years. So when you plug in those numbers, you get a principal of $2,500. That was the original amount you put in. Okay, example 8, we're going to use the last formula, which is distance is equal to rate times time. So the problem says we have a truck driver that averages 60 miles per hour while driving a freight to a customer. On the return trip, the driver averages 50 miles per hour due to construction. The total driving time is 6 6/10 of an hour. How long does each trip take? So we want to know the time there plus the time back, and that'll be our total time. So we have to get creative. So I don't know the time there, but I know that the driver drove 60 miles per hour. I don't know how long it took to get back, but I know that the driver was averaging 50 miles per hour. The total time I do know. So we know that this is going to be 6.6 of an hour. Now, time there. If I don't know the time there, let's look at this formula and what can we do? Well, if I solve for time, that means I'm going to divide both sides by r. So I can think of time as the distance over your rate. So let's put distance over rate for both of these. And the reason why is because I do know my rate. So the rate when we were going there was 60 miles per hour. So let's plug that in. We have distance over 60, that's miles per hour, plus coming back was the distance over 50 miles per hour, and that would equal 6.6. Now we need to add these. They do not have the same denominator. So let's give them the same denominator. I would multiply this top one by 5 and bottom by 5, and over here I would multiply it by 6 over 6. So I end up with 5d over 300 plus 6d over 300 is equal to 6 6/10. So now I have 11d over 300 is equal to 6 6/10. To solve for d, let's multiply both sides by 300. Okay, so we now have 11d is equal to 1,980. When we divide by 11, we get an answer that the distance is equal to 180 miles. Okay, we have not solved the problem because the problem is asking how long does the trip take, does each trip take? Okay, no problem. We can figure that out because when we go there, and I'll take a little bit of room from this other problem. Our trip there, the time is going to be our distance, which is 180 miles, divided by our rate. And there we average 60 miles per hour. So when you divide 180 divided by 60, you end up with 3 hours. So the trip there took 3 hours, and then the trip back, time is equal to, our distance is the same. We drove the same amount there and the same amount back. So 180 miles again, divided by the rate, which was 50 miles per hour. So when I divide 180 divided by 50, I end up getting 3 6/10 of an hour. So on the way there, it took 3 hours. And on the way back, it took 3.6 hours. I'd like you to pause the video and do the on your own part E. Here's the answer for the final question. So you end up getting 3 hours on the way there and 4 hours on the way back. This concludes your notes for section 1-5, day 2.